Hi, this is Jason Molesky. In this example, we'll pull together everything we've learned about describing relationships. Does the age at which a child begins to talk predict a later score on a test of mental ability? A study of the development of young children recorded the age in months at which each of 21 children spoke their first word and their Gesell adaptive score, which was the result of an aptitude test taken much later. So in this table, we can see our 21 children, the age in months of their first word, and their Gesell adaptive score. Now the question we want to answer is, should we use a linear model to predict a child's score from his or her age at first word? If so, how accurate will our predictions be? Let's use our four-step process. To do so, the first thing we'll want to do is make sure we look at our data in visual form. We always want to plot our data when we have it in tabular form. So here we have a scatter plot along with the least squares regression line. And since we have the least squares regression line, we can also look at a residual plot. And we have some Minitab output to help us answer our question. So the first part of our four-step process is to state our problem. In this case, we want to answer the questions, is a linear model appropriate for these data? And if so, how well does the least squares regression line fit the data? Now to plan this out, what we'll want to do to figure out whether or not a linear model is appropriate is look at that scatter plot and residual plot to see if the association is linear or nonlinear. Then, if a linear model does appear to be appropriate, we can use the standard deviation of the residuals or the coefficient of determination, r squared, to measure how well the least squares line fits the data. So, looking at the scatter plot and the residual plot, we can first note that the scatter plot does show a moderately strong negative linear association between the age of the first word and the Gesell score. Now notice here we did indicate strength, direction, and form. We always want to make sure we highlight those three elements when describing what we see in a scatter plot. Now note there are a couple of outliers in the scatter plot. The 19th child in this case has a very high Gesell score for his or her age of first word. Also, we note child 18 out here didn't speak his or her first word until much later than the other children in the study, and also has a much lower Gesell score. Now the residual plot doesn't show any obvious patterns, so that confirms what we saw in the scatter plot, that a linear model is appropriate for these data. Now let's use the Minitab output to determine how well a linear model would predict the Gesell score from age at first word. From the computer output, the equation of the least squares regression line is y hat equals 109.874 minus 1.1270x. Notice we look in the coefficient column in the Minitab output to design our equation, our least squares regression equation. The constant gives us the constant value, and the coefficient of our variable gives us our slope of the line, in this case the coefficient of x. Now in this case we didn't define our variables. It's always a good practice to define them, so you might want to make an extra note that y hat represents the predicted Gesell adaptive score, and x equals the age in months of the first word. Now the standard deviation of the residuals in this case is given by S, 11.0229. This means that our predictions will typically be off by about 11 points when we use the linear model to predict Gesell scores from age at first word. And finally, our coefficient of determination, r squared, is 41%. This means 41% of variation in Gesell score is accounted for by the linear model relating Gesell score to age at first word. Now, to conclude, we note that although a linear model is appropriate for these data, our predictions might not be very accurate. Our typical prediction error is about 11 points, and more than half of the variation in Gesell score is still unaccounted for. So while it does look like a linear model fits, it doesn't do the greatest job in terms of making predictions. Now, we should be hesitant to use the model to make predictions until we understand the effect of the two outliers in the regression results also. So in looking at that scatter plot, we had several values that didn't seem to fit the overall pattern, so we might want to look a little bit deeper into the situation before using the model overall. Now for some additional practice with putting all of our describing relationship information together, try exercise 67.